So first, recall relative homology groups. So this you can find on page 115 of Hatcher's book Algebraic Topology. So say A is a subspace of X, then chains in A will naturally sit inside chains in X, and then you can modulo out chains in A, and then you can get a short exact sequence like this. So we rewrite this as Cn of X comma A. Now you can put all these chains together, make a complete map of chain complexes, and you will get a short exact sequence of a map of chain complexes. So this is a chain complex associated with A, this is the chain complex associated with X, this is the chain complex associated with X comma A, which this X comma A means that these are the individual components which we have joined together to build this chain complex. Now if you have such a chain complex, then you obviously have a long exact sequence of homology groups. So you have hk plus 1 x comma a goes to hk of a x x comma a, then index decreases k minus 1 a, and so on. So this is assumed to be known. Now say you have X, which is a CW complex, and you already know that X is built out inductively. So you take an n cell, take its boundary and attach to n minus 1 cell, and therefore we have a natural filtration. You have the null set here. This null set is contained within these 0 cells. Then this to construct x1, you take a 1 cell, attach its boundary to 0 cell. To construct this x2, you take a 2 cell, attach its boundary to 1 cell, and so on. You construct a entire CW complex. So now we have a pair here, a comma x, which is like a is included within x. So corresponding to this, you can talk about some space, say xi minus 1 is included within xi. So rather than just talking about CW complexes, you could talk about any space. So xi minus 1 is included in xi, so you can write it like this, xi minus 1, this is included in xi. So corresponding to this, we have a new sequence here which comes from this pair xi minus 1 contained in xi. So again you have this long exact sequence. We have done nothing much. We have just taken this sequence, replaced x with xi and a with xi minus 1. So you have another sequence like this. Now rather than this pair, you could consider another pair. So another pair could be this xi is itself contained in xi plus 1. So this xi is contained within xi plus 1. So now you can think of this xi as a and this xi plus 1 as x. So corresponding to this pair, just this pair, we have another long exact sequence like this, xi plus 1 xi to xi plus 1 xi plus 1 xi, and so on. Now you can consider another pair. You can consider xi plus 2, and now you have this pair. I plus 1 is contained within I plus 2. So now you can have another long exact sequence which corresponds to this pair now. So you have xi plus 2, xi plus 1 going to xi plus 1, xi plus 2, this and this. So basically we are just repeating this long exact sequence which we learned from Hatcher, page 115. So we have to fit these three exact sequences together. So this long exact sequence you have to fit in a staircase diagram with this long exact sequence, with this long exact sequence, to get a spectral sequence or to get an exact couple. So let us repeat this argument for a filtration. So for filtration, we, instead of writing spaces like this, for any space x, you write its filtration. You write it here as fn plus 1, which would contain f of n and so on. Then you, instead of x2, you write f of 2, f of 1, f of 0. So this is null set, and here we are also saying that there is a null set here. So you can have a filtration like this. So the advantage of filtration is that you can, instead of spaces, you can put it on modules, you can put it on rings, and so many other algebraic structures. So if you have a filtration, then you apply the same principle we had before. So this fi minus 1 is contained within fi. So fi minus 1 is contained within fi. So you can form some kind of a chain complex corresponding to it. So you can form a chain complex like this. So you can say this is fi minus 1, this is going to fi, and this is fi modulo out fi minus 1. And this will give you a long exact sequence like this, and precisely this is the long exact sequence which we are copying here. So this long exact sequence corresponds to this pair fi minus 1 contained within fi. So you have this long exact sequence corresponding to your filtration. So again, you can have another long exact sequence corresponding to this filtration pair fi is contained within fi plus 1. So again, you can have a long exact sequence like this. Nothing we have been doing, we are just copying this result here for this pair. Or you can see that, you know, the model we built for CW complexes we are copying. So again, here you have another pair. You have fi plus 1 is contained within fi plus 2, and for this pair you again have a long exact sequence like this. So this you can use for rings and modules, because filtration holds for rings and modules. And so we have been able to construct long exact sequences corresponding to a pair of filtration. Nothing much, we just used the CW complexes as our guiding skeleton. So we are going to fit these three long exact sequences to get an exact couple from which we will get a spectral sequence.